All right, in this video, I'm going to go over how to find the interval of convergence for this one here and possibly another one. So the first thing I do when we are doing an interval of convergence is set up the ratio test, which I do L equals the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. So just to back up a moment, I got sigma n equals 1 to infinity of x to the n over n to the fourth times 6 to the n. It's got these x's in it, and that's part of the interval that I'm going to find. I'm going to find x values for which this thing would converge. So let's go ahead and do this. So it is the limit as n approaches infinity. Remember, this right here is the a sub n. So if I want to do a sub n plus 1, I'm going to go absolute value. I'm just going to change all those n's to n plus 1s. So I get x to the n plus 1 over n plus 1 to the fourth times 6 to the n plus 1. And I'm going to divide that by a sub n, which is exactly what I have written there next to the sigma. So I get x to the n over n to the fourth times 6 to the n. And absolute value. I'm going to come down here. That's equal to the limit as n goes to infinity of absolute value. I'm going to copy dot flip. I'm going to break this down into maybe more steps than you necessarily need to be able to do it, but hopefully that should be nice and clear. So I get x to the n plus 1 all over parentheses n plus 1 to the fourth times 6 to the n plus 1. I just copied this right here because I'm dividing a fraction by a fraction. So it's a copy, and then I dot for multiplication, and then I flip this fraction right here. Some of you might know that as multiply by the reciprocal. But that gives me n to the fourth times 6 to the n over x to the n. I just flipped that fraction. Absolute value equals limit as n goes to infinity, absolute value. Now, I'm going to group the terms that are similar together. So I'm going to go x to the n plus 1 over, so I'm taking this term right here. I'm going to group its similar term, which would be that one right there. So x to the n plus 1 over x to the n times, I'm going to take the 6 to the n next. So that gives me 6 to the n over 6 to the n plus 1. And again, I took the positive 6 to the n because that, or sorry, the 6 to the n in the top because that's in the top here, the n plus 1 in the bottom here. And then times n plus 1 to the fourth over, or sorry, I did that backwards, times n is in the top to the fourth over n plus 1 to the fourth in the bottom. All right, so this simplifies quite nicely. So I'm going to write my limits, even though I don't think we're going to need it next, but I'm going to write it anyway. All right, so what happens here? I get x to the n plus 1 over x to the n. Well, that leaves me with just x in the top of a fraction because there's one more x in the top than there's in the bottom. And then I have 6 to the n over 6 to the n plus 1. So that has one more 6 in the bottom. So I'm left with 1/6. And then times. All right, so what I need to do, I can't really cancel these the way I canceled those, but I can think about it because I have this limit here. The limit as n goes to infinity. Well, if you think about it, this 1 right here is not going to matter as n goes to infinity when comparing these two polynomials. So I'm just going to get an n to the fourth over n to the fourth. We've talked about that a lot in class. It just goes down to 1. So like that. That's the end of my absolute value. And that gives me the absolute value of x over 6. Remember, we always make that less than 1 when we're doing our interval of convergence. I'm going to give myself a little bit more space here. So what do? We go, I'm going to rewrite that line, absolute value of x over 6 is less than 1. So from here, you should know that algebraically, if something's absolute value is less than 1, then that something, x over 6, is between a negative 1 and a positive 1. Because for something, if I take its absolute value and make it less than 1, then it's going to be between 0 and 1. And then that same thing could be a positive version of itself, right? For example, 0.25 or 0.2 is less than 1. Negative 0.2 is also, if I take its absolute value, less than 1. We've talked about that, so hopefully that's good. It's kind of like the ratio when we're doing the geometric series test. But anyway, from here, I just multiply by 6. So I get negative 6 less than x less than 6. And remember, I'm multiplying by 6 on all sides, all pieces of this, kind of treating it like an equals or an equation with two equal signs. And that is almost my answer. What I need to do now is figure out what happens at the endpoints. I'm going to go ahead and write that endpoint. And I'm going to take x equals negative 6. I'm going to take x equals 6 first because it's going to be a little bit easier. X equals 6, and then I'll do x equals negative 6 over here. So I'll zoom out a little bit. What I need to do is plug x equals 6 into this right here. Watch what happens. I get sigma n equals 1 to infinity. When I make x equal to negative 6 here, I get 6, or x equals 6, I just get fraction bar at the top is a 6 to the n. And the bottom gives me an n to the 4th, and then the times another 6 to the n. Now, what I want to do is simplify this before I go and say what it does. Notice these guys cancel each other out, and I get that this is sigma n equals 1 to infinity of 1 over n to the 4th. Now, this one is one that we should be very familiar with. It's a p-series. So I'm going to say converges by p-series because p equals 4 is greater than 1. Remember, a p-series with the p-value, which is this 4 up here, that's bigger than 1, is going to converge. So I say that converges. So I'll show you what that means. This right here is the interval without considering the endpoints. If it converges at that x equals 6, what I need to do is include the 6 right here in the interval. So how do I do that? I write x less than or equal to 6 because that includes the 6 in the interval. And then I'm going to put my negative 6 here. We just have to figure out what sign goes here. So let's go ahead and do it for that one. This one, I'm going to plug, zoom out again, x equals negative 6 into this x value right here. This one's a little bit more work. This gives me sigma n equals 1 to infinity of negative 6 to the n over n to the 4th times 6 to the n. So that's the same as sigma n equals 1 to infinity. 2 times 3 squared is, well, what's 2 times 3? It's 6. That's 6 squared, which is 36. Remember, you can also do this as 2 squared times 3 squared, because 2 squared gives me 4. Oops, get out of here, little keyboard. 4, and then 3 squared is 9, and that gives me the same 36. So I'm trying to say here is that I can write this as sigma. I'm going to break it up into, well, here, I'm going to do it up here. That negative 6 to the n. This piece right here. I'm going to change the way that that looks. That's the same as negative 1 times 6 to the n, which that's in the form of this thing right here. I can go and write that as negative 1 to the n times 6 to the n. And the reason I can do that because this is the same as that, and all of the operations work in the same way here. But notice what happens if I replace this negative 6 to the n with this. That gives me negative 1 to the n times 6 to the n all over n to the 4th times 6 to the n. Again, these cancel, and that gives me sigma n equals 1 to infinity of negative 1 to the n over n to the 4th. Now, almost done. You may say, oh, I know this. It converges by alternating series. So I'm going to give you a quick reason why. First off, this series alternates. So we have that box checked. And then I just have to look at the rest of the series, which in this case would be 1 and that's 0. So this series here alternates, and the limit of the non-alternating piece is 0. So therefore, this thing converges by alternating series test, which I'm going to abbreviate as AST. So, whew, x equals 6 is a endpoint that converges. Notice x equals -6 also converges. So I'm going to write less than or equal to here as well. So this right here is your final answer for the interval of convergence for this problem right here. Hopefully this math makes sense. Quick summary: set up the ratio test, cancel things, get it into this form. We're always going to have this. 100% of the time when we have something like this, I go -1 less than the thing less than 1. And then I multiply out, I get my interval without having tested the endpoints, and I go and I check my endpoints. X equals 6, bam, converges. X equals -6, also converges. So this thing converges on the interval from -6 to 6, including those endpoints. Thanks.